Welcome to the ET302 how-to video on Diodes and Transformer Lab. Here we are at Multisim, and first thing we need to do is to download the zip files and unzip them and go ahead and open them up. And we're going to start with our first file, and we're going to go to the desktop where I put these on, and our folder, start PS1. Good. So let's go ahead and I'm going to enlarge this and center it. And here we have a standard diode circuit. So we have a diode here, resistor. We have our voltmeter where we're going to measure the voltage across our diode, and our voltage across the resistor, and our current meter. And we're going to have a voltage on our diode, and it is going to take away the voltage from our power, and remaining power and voltage will be left for our resistor. So let's go ahead and start it up. Okay, so the voltage on our resistor is going to be about 0.549 volts, reasonable. The remaining voltage will be left onto our resistor, and our current will be based on the voltage through the resistor. For our lab, we need to run our circuit and go ahead and put the diode voltage and the resistor voltage and the current, and then we need to make changes either to the voltage on the battery or the resistance. Okay, for our lab, for the next step, let's go ahead and turn it off, and if we need to change the voltage of the battery, go ahead and just change the voltage. Okay, if we need to change the resistance, go ahead and double click on that and just change the resistance in the box. And let's go ahead and open up the next lab. Okay, here we have our resistor and diode circuit. Here we have two diodes. They're both forward biased. And so we'll go ahead and we need to subtract out both of these voltages from our diodes and take it away from the voltage that'll be left over our resistor. So let's go ahead and start it. Okay, so we have 0.493, 0.493, so we're going to subtract this, which is about 1 volt, from our resistor, and 12 minus 1 is right around 11, and then that current will be left across our diode, across the, the resistor. Good. Okay, so let's power off and go ahead and open up our next file. So here's our next circuit. And what we have here is a reverse bias diode. This arrow needs to point to ground in order for it to be forward biased. So it will not conduct. So let's go ahead and turn it on. And we're going to have all of our voltage across the open of this diode. And we'll have zero current. This is nanoamps, so it's close to zero as you could get. And so we have no current flow and the full amount of the voltage across our diode. Okay, so let's turn off our simulation and go to our next file. Okay, here we have a parallel circuit. We have a voltage we have a diode and we have a resistor, and then in parallel we have another resistor. Our voltages are going to be the same in both of these legs because of they are in parallel. Okay, so let's go ahead and start it. Turn on our meters. Okay, so what we have is we have 12 volts. So each leg is going to be a total of 12 volts. So our resistor by itself is going to be the same voltage. So let's go ahead and open this one up. We have 12 volts. So 11.5 plus about 0.5 should be 12. So our voltages will be the same in both of these circuits. Okay, let's open up our transformer files. And here we have a transformer circuit. And we are going to compare our voltages with a DMM and oscilloscope. So let's start it up. Okay, both of these DMMs are measuring an RMS, root mean squared, which is a average of our sine waves. So let's go ahead and pause this so we can take a look at our scope. And what we have here is a quarter for our turns ratio, and these turns ratios are opposite than what we typically do. So this is actually a 4 times 4 turns ratio. So we're going to increase our voltage by 4 across here. So we have 100 volts on our primary, and we're going to have 400 volts on our secondary, and those are RMS. So let's go ahead and take a look at our oscilloscope, and we're going to do our peak measurements. And so right here we have a peak of about 140, which is good, and we have about 558 on our second one. So our peak to peak would be about 140 to about 400 volts. So we have a increase of 4, and we could see that our peak to peak is much higher than our RMS. Okay, so let's shut down this simulation and open up our last file. And here we have a transformer circuit. And this time we're measuring current. So, and as we remember, we have an inverse relationship between current and voltage. So let's go ahead, and this one should be current, sorry. This one would be voltage, and this one should be current. Good, now we're stabilizing, so let's go ahead and bring this up. Bring this up. Do we have the same? And let's go to 200, and let's guide this guy 200 too. All right, so let's pause it. All right. And okay, these need to be AC, so let's go ahead and restart it and make these AC, AC, AC. Good. And pause it so we can see our oscilloscope here. There we go. Okay, so what we have here, and do we have a offset? We do not. Good. Okay, let's go ahead and run it. So let's get started here. So we have 100 volts here, and we have a 300 volt output. So we have about gain of 4, and we do have a gain of 4. Okay, and so when we have a gain of 4 voltage, we're going to drop by a factor of 4 on our current. So here we have 145, and we have 36 out. So we have a loss of 4 and an increase of 4 on our voltage. So that's normal. So we're going to have an increase in voltage, and we're going to have a same ratio of a decrease in current. Good.